Today we're doing the first set of exponential notes, and we're going to be focusing on graphing exponential functions. At the top of your page you see that f of x equals a times b raised to the x power. So a represents your scale factor, b represents your base, and the base can be any value except 1 or negative 1. Reason being, if I used a base of 1, when I raise 1 to any power, I will always get 1. So this will not create an exponential function, it will just create a linear line. And x is going to be our variable. The variable must always be in the exponent spot for it to be considered an exponential function. So we're going to start with creating a graph. We're going to do this by hand. To the left of the graph there is some space, and you're going to create a t-chart next to your graph. So you'll see domain range ABC, there's a little space in between that and the graph, so put your t-chart there. So we are going to do values of -2, -1, 0, 1, and 2. So we'll start with 0. So 2 raised to the 0 power is 1. Anything raised to the 0 power is 1. 2 raised to the first power, and again I'm plugging these x numbers into the exponent right there. 2 to the first power is 2, and 2 to the second power is 4. Now we'll do some of the negatives. So I'm going to go down here and write this to show you how it works. If I do 2 to the negative first power, we talked about rules of exponents in the last chapter. Negative exponents just mean we send the whole thing to the bottom of a fraction, and now the exponent becomes positive. So 2 to the negative first power is really 1 over 2 to the first power, which would be 0.5 or 1/2. So similarly, if I did 2 to the negative second power, this would become 1 over 2 to the second power, which would be 1 over 4, which is 0.25. So we're going to plot these coordinates down. So I have -2, 2.5, -1.5, 0, 1, 1, 2, and 2, 4. And obviously if I wanted more coordinates, I could plug them in. So for example, 2 to the third power is 8. So I could plot the 0.38. And we're going to go ahead and connect our dots. And this side is going to keep traveling. So going to the left is going to get very, very close to 0, but it will never be 0. Reason being, if I'm raising anything to the negative exponent, it just sends it to the bottom of the fraction. So notice we're never going to be able to achieve a negative output because the negative exponent just sends it to the bottom of the fraction, so the fraction remains positive at all times. So this function is getting very, very close to 0, but will never touch 0. So my domain is all real numbers. I can raise 2 to any power I want. My range, however, is y is greater than 0. If you look at your y values, notice we have 0.25, and then the next one would be, if I raised 2 to the negative third power, I'd have 0.125, and the decimals would keep getting smaller, but would never get to 0. Letter C, so the first one, as my x values increase, so as my x values could go towards infinity, f of x is going towards infinity, so the top one's infinity. And then the second blank, as my x values go towards negative infinity, my y values go towards 0. Letter D, my average rate of change from 0 to 2, so here would be 0. And if we use, let me use this, so from 0 to 2, I'm rising, and then the run, so notice we went up 3 over 2. So my average rate of change is 3 over 2. Letter E, x-intercepts would be none, or DNE, because this will never cross the x-axis. Letter G, my y-intercept is 1. Letter H wants to know where my y values are positive, so it says where is f of x greater than 0? Well, all of my y values are positive, so the entire number line is shaded in. Letter I says where are your y values less than 0? That doesn't happen on this graph, so there is nothing shaded for letter I. So we're going to flip the page and do the second problem on this bracket. So the second function says f of x equals 1/2 raised to the x power. So again, make a t-chart. You can put it, just get it somewhere on your page. You could go to the left of the graph or below the graph. And again, we're going to use the same values of -2, -1, 0, 1, 2. So let's again start with 0. If I raise anything to the 0 power, it's 1. 1/2 raised to the first power is 0.5. 1/2 raised to the second power. So 1/2 raised to the second power means I have 2 1/2. So this is the same thing as saying 1/2 times 1/2. And 1/2 times 1/2 is 1/4. So my output would be 0.25. So now let's raise it to the negative powers. So if I raise this to the negative first power, again, remember that the negative switches your fraction and then the exponent becomes positive now. So this 1/2 will become 2/1 to the positive first power. And 2/1 raised to the first power would just be 2. And now 1/2 raised to the negative second power. Again, we'll flip the fraction, becoming 2/1 raised to the second power. So 2 squared would be 4. So we're going to plot these points. So I have a -2, 4, -1, 2, 0, 1, 1.5, and 2.25. So this is what we call exponential decay, because notice it's decreasing over time. So my domain, letter F, the domain is all real numbers. Again, I can raise 1/2 to any power. There is no domain restriction. I can use every x value. My range, however, is still y is greater than 0. All my y values are positive. Letter I, as my x values are increasing, so as I go towards the right, my y values are going towards 0. As my x values are decreasing, or as I go to the left, my y values are now increasing. Letter I, we're going from 0 to 2, and this one's a little tricky. So we're going from 0 to 2, and it might be easier to use our coordinates over here. So 0, we're dealing with 0, 1, and 2 is 0.25. So let's do this algebraically instead of graphically. So my y values are going down by 0.75. So the change in y is 0.75. My x values are going up by 2. And if I divided this out in the calculator, you get -0.375, I believe, which would be the same thing as -3/8. So this would be your final answer. X-intercepts, again, none. D&E will never cross the x-axis. Y-intercept is 1. Letter I says where my y value is greater than 0. That happens the whole time. Notice if you look in your t-chart, your y values are all positive. The second letter I, which is a typo, where it says f of x is less than 0, well, if you notice, your y values are all positive, so there is no negative y values. So this again would be D&E. So that's all for today. If you have any questions, please jot them down.